So the design matrix. How does a team work together to decide which design is the best for a given task? So that's where you use the design matrix. Now, this matrix procedure can be used really for any complicated decision. It's especially good when you have a team involved, but even working individually, it's a good way to think about, to organize your thoughts as you're making a big decision. What we're going to be talking about specifically is as part of a design. So for your particular project, when you're designing the Rube Goldberg machine, each student needs to come up with 2 alternatives. These are like alternative tasks for the Rube Goldberg machine. And then as a team, you're going to sift through these and decide which are the best ones you want to go with. So this is how you decide which is the best idea. Okay, this following the design matrix. A design matrix is a common engineering technique to make objective decisions between design alternatives. The team goes through the following process to develop their design matrix. Okay, the first thing you do is develop the design criteria, and I'll be going through each of these steps in more details. And then you weigh the design criteria, you develop alternatives, you score the alternatives based on each design criterion, and then you total the scores for each alternatives. From that, you've got your winning design. So you might wonder, how much of this do you do individually and how much are you expected to do as a team? So let's go through each one of these and I'll talk about whether you're expected to do it as a team or do it individually. So the first task there, develop design criteria. That is something you will come up with as a team. Okay, so as a team, you'll come up with all the criteria that you want to have for each, in your case, for each task that's in the Rube Goldberg machine, each particular step. And for, in general, if it was senior design, this would be design criteria for a particular part. Then you weigh the design criteria also as a team. Your team will establish the weights for each criterion. So which criterion is the most important, which is the least important? You're going to do that as a team activity. Developing alternative designs, you'll do that as an individual activity. Spoiler, all the rest are teams. The scoring alternatives on each design criteria you will do as a team, and the coming up with the total scores and making your final decision, you'll do that as a team as well. Now, when you are working as a team, I often see this amateurish step where instead of actually discussing this, people try to do this by email or text. And each person comes up with a particular, say, weight, and then somebody just averages what everybody thinks. That is not working on a team. Working on a team means that you are give and take. You're saying why you think something's important. Another person is talking about why something else is more important. You debate it. You come to a consensus as a team. It is not just averaging what everybody thinks. That's working as a group of individuals. That's not working as a team. And it's really important you get out of that. Sometimes, I guess it's easier, just to see what everybody thinks and kind of average it all together. Sometimes that is easier, but it's not as effective. It's not nearly as effective. So when I say team activity, what I mean is you are together, either, on video, on a phone call, in person, ideally. You are together, you are discussing each thing, okay? So I just wanted to define, what do I mean by a team activity? That's what I mean by a team activity. Okay, so the design matrix, these are the steps. Now I'm going to go through, as I said, I'm going to go through each one of these in some detail. So the first step, developing the design criteria. All right, so you list the criteria that are most important to your design. Now, this is always going to be application specific, but these criteria will often include safety, cost, effectiveness, performance, durability, ease of manufacturing, availability of parts, ease of use, aesthetics, sustainability, versatility, and there might be others. I know in the Rube Goldberg machine, you're probably thinking of something in addition to these like really basic ones. You don't have to use all of these, by the way, just whichever ones you think are most important to your design. Or in your case, in the Rube Goldberg machine, you are selecting steps that each person's come up with at least 2 steps for the Rube Goldberg machine, and you are deciding which ones you like the best. What might you add to this that is different than like a normal engineering design? These ones are real standard, but a Rube Goldberg machine is not standard.
We did whimsy.
Whimsy, yeah, that's really good. That's a good way of putting it. Whimsy, yeah. So that's something I would apply to this. Yeah, add to this rather. These are just the standard ones for a normal engineering design. Okay, after you'd come up with your design criteria, then you need to weigh them. I want you to weigh each criterion from your list of the criteria that you just developed between 0 and 1. Okay, and the higher the weighing factor, the more important that criterion is to the ultimate success of your design. Now, I do want you to do between 0 and 1 for the criteria. Weighing the criteria, I want those weighed between 0 and 1. Obviously, a 0.95 is the same as a 9.5 if you were weighing them between 0 and 10. You know, obviously it's equivalent, but your equation will be a little bit easier if you have the weights different than the alternative scores. Alternative scores, I'm going to have you go between 0 and 10. And this is mandatory that I want you to use these weights, these numbering schemes. Okay, after you weigh the design criteria, then you develop alternative designs. Now, remember, this is done individually. Okay, so this is when individual creativity really comes through. Each team member is expected always to develop at least one design alternative. Note, commonly as your team discusses the alternatives, an additional alternative known as a hybrid is developed that includes the strengths of the individual designs. Okay, and I just want to point out again that for the Rube Goldberg machine, for product realization, 2 alternative steps are required for each person, not just one design alternative. Typically, if you're coming up with a way to, I don't know, something, if you're designing some sort of widget, typically each person will come up with one design, but not in the Rube Goldberg. Okay, that is developing the alternative designs. Then you're going to score the alternatives on each design criterion. Okay, this should be done as a team. This is a team decision, so you're back to the teamwork. Score each alternative. I want an alternative scored between 0 and 10. And then I want, using a weighing calculation, you will total each alternative. And we'll go through an example of what I mean by a weighing calculation, but essentially you're taking the score of some design, some alternative on a particular criterion. You take the score and you multiply it by the weight of that criterion. Just like in a GPA, you take the grade you earned. Like if you earned a 4.0, you multiply it by the number of credit hours that class is worth. So in this case, you're taking the score and you're multiplying it by the weight of that criterion, and then you sum them all up. Then you total the scores for each alternative. Okay, the design alternative with the highest total score is the winning design, and it must be selected. You do not want to put that some other alternative is the winner, but not select it. It looks like you don't know what you're doing. And so every once in a while, I'll see some freshmen do that in Intro to ME, but don't do that. Don't do that. You never select an alternative, and as I'm going to say again, never select an alternative that does not have the highest score. But that being said, what if you strongly feel that the winning design is not the one you want to proceed with? This happens. It actually happens more than you might realize, where there's one that won it on paper, but God, you can't imagine going with that alternative. So if that happens, what you should do is reevaluate the list of design criteria. Is there something that you overlooked? The design criteria weights. Maybe you said that durability was like the weight of durability was a 0.4, but as you think about it, it's really more like a 0.8 because it's really got to be durable, or vice versa. Okay, the weights. And then finally, the design alternatives per alternative scores per criterion. So reevaluate all of that. If the one that you think should be winning is just not the winner. It's not that you're going to fudge the numbers, it's that you're going to find that there's probably, what I find most often has happened, is that there's a design criteria that I just omitted. I just absolutely did not think of that until I looked back and looked at the matrix I had and what it was pointing me to. Okay, what if you still don't feel that's what's going on? Check your ego. Why do I say check your ego when you're looking at which alternative is the winning alternative? Are you extra fond of an idea just because it's yours? This happens. It's just human nature. Sometimes when you come up with an idea of how something should be done, or could be done, I guess, if you come up with an idea of how it could be done, it's really easy to transition to that's the way it should be done. And you get kind of married to that idea, and it's hard to look at it from a different perspective. So think about your ego and get your ego in check. Also, if all else checks out and you're sure that your design matrix is complete, you've got your ego under check, and if all else fails and it's just you're not nuts about the idea that everybody else is nuts about, you just need to deal with it. You are working on a team. Don't tune out just because they're not taking the idea that you thought was the winner. Just continue working, and you just need to deal with it sometimes. Okay, any questions on this? That is the design matrix process. Okay, that is the design matrix process. Fast, got lucky, caught a break. Okay, so can everybody see? This is actually my iPad. We're going to go through an example of a design matrix, and the example I'm going to go with is, you gotta be kidding me. Okay, looks like it doesn't mind. Okay, so the example I'm going to be going with is if we were doing a pumpkin launcher. Whenever you do a design matrix, it should be in a table. And across the top, I'm going to put the weights, the criteria. And down here, I will have the weights. I'm going to do this in red. Okay, so I know that, half of you did a pumpkin launcher and probably half of you didn't do a pumpkin launcher if you had me, or if you took intro during a semester other than fall. So these are the design criteria that are most common. And let me try to show them on one screen. Okay. So looking at these, and this is going to be a total right here. 1, 2, 3, 4, 5, 6. So thinking of 6 design criteria that are important for the pumpkin launcher. What would you think is one of them? Pumpkin launcher, by the way, is this Thursday. Yeah, dynamic. Oh, are any of you doing the pumpkin launcher this semester? Because Dynamics is doing it. Anybody doing the pumpkin launch? Dr.
I'm doing it.
Sarmas? Oh, somebody's doing it. Okay.
Yeah,
How's
I
it going?
It's going all right. We got a pretty good machine. I'm pretty excited about it.
Good. Did you also do it in intro?
No, ma'am, I did not.
Okay.
I had Dr. Sarmas for intro, and we didn't do it.
Okay.
Yeah.
Yeah. And so you must have Dr. Sarmast also for Dynamics.
I do. Yes, ma'am.
Yeah, he's the only professor doing it this semester. Dr. Vise is not involved. Is Dr. Vise involved with it? Has he come to talk to your class about it or anything?
He is not. No.
Okay. Yeah. Okay, so I'm assuming you did a design. Did you do a design matrix?
We did not. We were basically just told go build something and see if it works. I probably
Oh
shouldn't
my-
be saying that actually.
Oh my God,
No.
really?
Yes, we did. Yes, we did.
Okay. Well, I know it's got a different focus since it's in dynamics, so there's a lot of equations that are used. See, my thought though is dynamics is a very full class. Dynamics is so much harder than statics, and building the pumpkin launcher is kind of a big deal. Okay, so if you were looking at these criteria, which is one that jumps out at you as something you should probably be thinking of?
Distance.
Distance. Okay, let's put that under performance. I happen to have that one here as the third. I just in no particular order. Performance, absolutely. So the distance it throws is relevant. You want it to, not embarrass your team. What else?
Affordability.
Affordability. Yeah, I've got it as cost and
Durability.
durability. I actually don't have that one in the example I came up with. But yeah, durability, because you want it to work more than one time. I can see where that would be on here. What about safety? Every once in a while, a trebuchet will shoot backwards. And it used to be in that Norton field between the two dorms. And they would shoot backwards right into the crowd sometimes. It was like safety is a really big thing. And you've got a lot of force around and, whipping around. And so, yeah, definitely safety. I have portability as one of them because you need to be able to remove it from the field and get it set up in a certain amount of time. What about ease of manufacturing? And ease of manufacturing with the Rube Goldberg machines, definitely something you want to think of too. And then the last one I have is just aesthetics, which isn't the most important thing for the pumpkin launcher. But, if it looks good, it's nice, but it's certainly not more important than durability. This is just an example. Okay, so you have your list of criteria, and you might have more criteria than this. You might have less, but it's hard to imagine having many fewer than 6 things you're thinking of. So now you need to weigh them each, and I want the weights between 0 and 1. So looking at what you have, what is the most important thing that you listed? This is how I come up with the weights. And the book goes through alternative methods to come up with the weights. I usually just compare them. They're all relative to one another. Having had this experience of them shooting back into the crowd, and if you were hit by a 10-pound flying pumpkin, you could really be injured. Or if the machine were to fall apart as it was whipping it around, if you had a trebuchet. What do you think I'm going to put as number 1 as the highest weight?
Safety.
Yeah, safety.
In when I took intro with Vise, it was a requirement that safety on our design matrix was at least 30%.
Good. Yeah, and sometimes then you still have to go through the safety inspection. I did the safety. I made my students do pumpkin launch one year, and then all the falls after that I let them vote. Except last fall, I don't think I let them vote. Because they never ever voted for the pumpkin launch because mainly because of the cost involved. Cost. So we know that the pumpkin launch is expensive. So let's say that your team came up with that as a 0.80. Performance, it depends, performance depends on, you want to do well and there's pride in your work. Is it more important than cost? Well, when something can be as expensive as a pumpkin launcher, it's probably not. For this example, I have that as a 60. Portability. Portability is super important with the pumpkin launch because you only have a certain amount of time to get it on and off the field. And you're not allowed to, at least in previous years, you haven't been allowed to test on campus. You need to be testing it somewhere else. It has got to be portable. So let's say your team came up with that as 0.85. Ease of manufacturing. Yeah, that's pretty important. Let's say your team came up with a 70. And aesthetics, yeah, not nearly as important as anything else. Maybe your team came up with a 15. Okay, so as I say, there are other methods that are outlined in the textbook about how to come up with these scores. But for this example, let's say your team came up with this. What I want you to point out is that everything's between 0 and 1. It just makes the calculations easier to read, easier to prove. Okay, let's say you have 3 teammates. And I'm sorry for those of you that had me for intro. I know this is familiar. The PowerPoint was new, but the example is not. Let's say you have alternative 1, alternative 2, and alternative 3. And alternative 1, okay, so you've got 3 different teammates that have each come up with one design for a pumpkin launcher. And let's say alternative 1, let's give him the name of Fred. This is Fred's design. Okay, so Fred's design probably won't kill anybody, but it might maim them. So they might lose a limb, but they probably won't lose their life. And, maiming is to be horribly disfigured. It's a disfiguring when it comes to safety. So would it score high or low on the design matrix?
Wow.
Low, absolutely. Let's give it a 1. And these are going between 0 and 10. Let's give it a 1. All right. So what's actually happened here is that you're together as a team and each person is giving you their elevator pitch about their design. So what actually happens in practicality? They're giving you an elevator pitch about their design. So Fred takes 30 seconds or a minute and tells you, it shows you the sketches and tells you the highlights of their design. So you notice it is not safe. And then you get together as a team and you come up with scores. So you notice it's not safe. Let's go through your own personal observations. Cost. Well, yeah, very expensive. So it'll probably bankrupt the team. And performance. Well, you look at it and we'll come back and put the scores in. So these are your thoughts. Performance, yeah, you think it'll throw to the Kennesaw campus. Obviously, that is an exaggeration, but it would really throw. Portability, yeah. Fred says that, like if you use his, you can use his truck. So Fred's not your ideal teammate here, because he's giving the impression that you can't use his truck if you don't go with his design. So he's kind of a jerk. Ease of manufacturing. Well, Fred's dad has apparently told you that if you go with his son's design, you can use his manufacturing shop. He's got some machine shop in his garage or something. Aesthetics, Fred has an eye. It is very pretty, almost delicate looking. Okay, so when Fred gives you the elevator pitch, these are your observations. You write them down because these are your observations that are key to the matrix. Okay, now the whole maiming somebody, clearly not good. So your team has now come up with a number. You've talked it through. You decided to score it as a team, you're scoring it as a 1. The bankrupting, yeah, it's going to be very expensive. So it has a high cost. Does that mean it'll score high on cost or it'll score low on cost?
Low.
Yeah, because you don't want it to be high cost. When you're thinking about cost, the cheaper the better. So this is expensive, so it's not going to score high. Let's say your team came up with a 2. Throwing it to Kennesaw campus, your team came up with a 9. You really think it's got a good design when it comes to the actual performance, assuming it doesn't kill anybody. The whole using Fred's truck, yeah, that's good. And then Bob's dad's shop, yeah, that's good. Maybe it's not in the best location, maybe it's not close to you, but that's good. Aesthetics, it is very pretty. That's good. Okay, so these are the numbers your team has come up with. Now you need to total them, and this is when you do the weighing calculation. So you take the score and you multiply it by the weighing factor, the score of an area of a criterion times the weighing factor of that criterion. So it's 1 times 0.95 plus 2 times 0.80 plus 9 times 0.60. Everybody see what I'm doing here? Plus 9 times 0.85 plus 8 times 0.70 plus 9 times 0.15. And this is equal to, if you do the math, we get a 22.6. So scored a 22.6. Is that good or bad?
We don't know it's comparing others.
Yeah, you have no idea because you need to compare that number to the others. So let's say that alternative 2 scored a 19.8 and alternative 3 scored a 21.4. Which one are you going with? Which one must you select?
Fred's.
Fred's. You've got to go with Fred's. This is when you feel like you've had a gut punch because you're looking back on this and holy smokes, you do not want to go with Fred's. And so you look back on this and this is when you can think to yourself, and this happens more often than you would imagine. You think to yourself, boy, I just don't like this. I think we've got a problem here. So looking back on this, were any mistakes done? I see a glaring mistake. Does anybody see a mistake here? And there's not a mistake with the math. I mean, there might be a mistake with the math. Let's just assume the math is correct. I don't like
portability.
This. Oh yeah, yeah.
I was gonna say the portability weight was maybe a bit high.
Yeah, but if it's not portable, you can't. If you can't get it to and from the field on time, some of these become a go no go because it must be portable. There's not degrees of portability as long as you're within that amount of time you have to set up. Then there's degrees of portability. What I see as super problematic here is safety. Since when is it okay to think, oh yeah, it won't kill somebody, it'll just like forever disfigure them? That is not acceptable. So keep that in mind, that, you know, sometimes Fred's is clearly not acceptable if it's going to maim. And again, maim is, you know, often like losing limbs. You don't think it'll kill somebody, but it'll likely maim them. That's just not acceptable. So that becomes just disqualifying. Okay, but beyond that, looking at this, you know, we don't have a team hybrid. And the thing that was really remarkable about Bob's was the performance. That's what was really stood out on Bob's. And yeah, maybe portability is too highly ranked. Maybe, you know, the top 3 contenders, they all were somewhat portable. You could get it to campus in time. But perhaps looking at your numbers, perhaps alternative 2 was really good on safety. And maybe alternative three scored the best on cost. So then what will typically happen is you'll notice the best things about some of the alternatives, and you'll use those to develop a hybrid. And this is, the hybrid is often going to be a compilation of the best features of some of the alternatives, and 9 times out of 10, it'll score the highest. If you truly have selected, if you've truly been inspired by the best things about the other designs, then often that hybrid is going to be the winner. Okay. Again, if you have a gut punch where something is being selected and you just really don't feel good about it, think to yourself, are there any criteria that are missing? I find it's the missing criteria. Notice what's not on here, durability. Durability is not on here. It's missing. So durability should be added. So let me go over here, like add durability. You are not just shooting this one time. So the oversight of durability, that's a mistake. And then look at the weights you have. You know, are you happy? You know, first look at the list. Is there something missing? Like something sometimes is pretty obvious, like durability just doesn't make your list. And then look at the weights. Do you still agree with them? And then look at the strengths and try to come up with a hybrid. Also, think about things that are disqualifying. In this case, Fred's, unless they made serious changes to the safety in its current formation, it is disqualifying because it's not appropriate to think that anybody's going to be seriously injured, let alone maimed, in an accident related to the pumpkin launch or anything.